Solve the system of linear congruences using Chinese remainder theorem for x is congruent to 3 mod 5, x is congruent to 2 mod 6, x is congruent to 4 mod 7. First step, we have to take a1, a2, a3 value, m1, m2, m3 value. Here, by the given data, we can take a1 as 3, a2 is 2 and a3 is 4. Similarly, m1 is 5, m2 is 6 and m3 is 7. Next step, we have to verify that GCD of this 5 and 6 is 1 and 6 and 7 is 1. Similarly, 5 and 7 is 1 or not. For that, we have to verify the GCD using this form. Here, first is we have to verify the GCD of 5 and 6 is 1. Here, we have to take the divisors of 5 and divisors of 6. Then, we have to find the greatest common divisor among these two. Here, divisors of 5 is 1 and 5 itself because 5 is a prime number. Similarly, the divisors of 6 is 1, 2, 3 and 6. Here 2 divides 6, 3 divides 6 and obviously 6 divides 6. So this is not, 6 is not a prime number, but the divisors of 6 is 1, 2, 3 and 6. Here divisors of 5 is 1 and 5. Among these two, the common divisor is here we have 1, here we have 1. So common divisor is 1. Only one values, that is the greatest common divisor for 5 and 6. Therefore, the GCD of 5 and 6 is 1. Similarly, you can verify for 6 and 7 and 5 and 7. So obviously, these three values are equal to 1. That is GCD of these three values 1. Next step, you have to take m is equal to m1, m2, m3. So you have to multiply m1, m2, m3 value. That is 5 into 6 into 7, we get a value as 210. Therefore, we get m value as 210. After obtaining small letter m value, we have to verify that is capital Mk, which is equal to m by mk for k is equal to 1, 2, 3. So, substituting k value as 1, 2, 3, we get m1 as m by m1, that is 210. That is m is 210 divided by small letter m1, that is equal to 5. That is 210 divided by 5 is 42. Similar way, capital M2 is equal to 210 divided by small letter m2 is 6. Therefore, we get 210 by 6 is 35. Similarly, capital M3 is 210 divided by small letter m3 is 7. We know that 210 by 7 is 30. So, we obtain capital M1, M2, M3 value. Next, you have to consider a linear congruence as mkx congruent to 1 mod mk for k is equal to 1, 2, 3. So, we get a linear congruence as here m1 is 42. 42x congruent to 1 mod. Here small letter m1 is 5. Similarly, m2 is 35x congruent to 1 mod small letter m2 is 6. Similarly, capital M3 is 30x congruent to 1 mod small letter m3 is 7. Next step, by inspection we have to find the x value. That is, by inspection, x1 is equal to 3. Here, if we substitute x is equal to 1, 42 into 1 is 42 is congruent to 1 mod 5. So, 5 divides 42 minus 1 is 41. So, 5 does not divide 41, that the x is equal to 1 not satisfied. If you substitute x is equal to 2 means we get 42 into 2 is 84 is congruent to 1 mod 5 is 5 divides 84 minus 1 is 83. Also 5 does not divide 83. We substitute x is equal to 3, that is 42 into 3 is 126 is congruent to 1 mod 5, that is 5 divides 126 minus 1 is 125. Obviously 5 divides 125 satisfied, therefore x1 is equal to 3. Here if you substitute x is equal to 3, the congruence is satisfied. In the similar way, if you substitute x is equal to 1 means 35 is congruent to 1 mod 6, that is 6 divides 35 minus 1 is 34, that is 6 does not divide 34, so it's not satisfied. If we substitute x1 is equal to 2, 3 and 4 and etc., we get x value is equal to 5. If you substitute x is equal to 5 means 35 into 5 is 175. 175 minus 1 is 174. Obviously 6 divides 174 satisfied. Similar way, if you substitute x is equal to 4, the congruence is satisfied. Therefore, by inspection method, x1 is 3, x2 is 5 and x3 is 4 here. So, we obtained x1 value, x2 value, x3 value, m1, m2, m3 value and a1, a2, a3 value already known. Therefore, finally, the unique solution of system of linear congruence is given by the formula x is congruent to a1, m1, x1 plus a2, m2, x2 plus etc. up to ar, mr, xr under mod m. So, we have to substitute all the values here. A1 is 3 into m1 is 42 into x1 is 3 plus a2 is 2 into m2 is 35 into x2 is 5 plus a3 is 4 into m3 is 30 into x3 is 4 under mod m value is 210. So after simplifying these values, we get x is congruent to this value becomes 378 plus this value is 350 plus this value is 480 under mod 210. Finally, we get x is congruent. If we add these three values, we get as 1208 mod 210. So we have to reduce this to a smaller value. So we have to divide 1208 by 210. So we get here 210 into 5, we get as 1050. So if we subtract these values, we get a value as 158, which is a lesser value. This subform, we know that 1208 is congruent to 158 mod 210. So in the place of 1208, we can substitute as 158. Therefore, we get x is congruent to 158 mod 210 is a unique solution for the given system of linear congruence. This completes the problem. We shall move on to another problem. Solve the system of linear congruence using Chinese remainder theorem for x is congruent to 5 mod 3, x is congruent to 2 mod 5, x is congruent to 1 mod 11. Here also first we have to take a1, a2, a3 value, m1, m2, m3 value. Here a1 is 5, a2 is 2, a3 is 1. Similarly m1 is 3, m2 is 5 and m3 is 11. First we have to verify the GCD of 3 and 5 is 1, the GCD of 5 and 11 is 1 and GCD of 3 and 11 is 1. Using this method, here obviously 3 and 5 GCD is 1, we can check for 5 and 11. Here we have to find the divisor of 5 and divisor of 11. Here divisor of 5 is 1 and 5 because 5 is a prime number. Here similarly the divisor of 11 is 1 and 11 because 11 is also a prime number. So the greatest common divisor among these two is 1. Therefore the GCD of 5 and 11 is 1. Similar way 11 and 3 GCD is also 1. After verifying the GCD value, we have to take the product of m1, m2, m3 value as m. So we get m1 is 3, m2 is 5 and m3 is 11. So the product of these three values 165, that is value of small letter m. Next we have to find capital MK value, that is m divided by mk. Substitute for k is equal to 1, 2, 3. We get m1 value as m is 165 divided by mk, that is m1 is 3. That is 165 by 3 is 55. Similarly, m2 is 165 divided by m2 is 5. Therefore, we get m2 value is 33. Similarly, m3 is 165 divided by m3 is 11. So, we get 165 by 11 is 50. Therefore, we get m1, m2, m3 value. Next, you have to consider a linear congruence as mkx congruent to 1 mod mk for k is equal to 1, 2 and 3. So, we get first congruence as here m1 is 55x congruent to 1 mod small letter m1 is 3. Similarly, m2 is 33x congruent to 1 mod small letter m2 is 5. Similarly, m3 is 15x congruent to 1 mod small letter m3 is 11. Next, by inspection method, we have to find the x value for this and for this. So we get by inspection x1 is 1 here. Here if we substitute x is 1, 55 into 1 is 55 is congruent to 1 mod 3. Therefore we get 3 divides 55 minus 1 is 54. Obviously 3 divides 54. Similarly if we substitute x is equal to 1 here, 33 minus 1 is 32. So 5 does not divide 32. If we substitute x is equal to 2 means 33 into 2 is 66, that is 66 minus 1 is 65. Therefore 5 divides 65 satisfies. So x2 is 2 here. In the similar way x3 is 3 here. If we substitute x is equal to 1 means 15 minus 1 is 14. 11 does not divide 14. If you substitute x is equal to 2 means 15 into 2 is 30. 30 minus 1 is 29. That is 11 does not divide 29. If you substitute x is equal to 3 means 45 minus 1 is 44. That is 11 divides 44 satisfied. Therefore x3 value is 3. Therefore, we obtain x1, x2, x3 value, m1, m2, m3 value and a1, a2, a3 value we already known. Therefore, finally we have to substitute all the values in the formula, that is the unique solution of system of linear congruence, which is given by x is congruent to a1, m1, x1 plus a2, m2, x2 plus etc. and so on, ar, mr, xr under mod m. So, substituting all these values, we get x is congruent to a1 is 5 into m1 is 55 into x1 is 1 plus a2 is 2 into m2 is 33 into x2 is 2 plus a3 is 1 into m3 is 15 into x3 is 3 under mod m is equal to 165. So simplifying all these values, we get x is congruent to this value is 275 plus this value is 132 plus this value is 45 under mod 165. So if you add all these values, we get x is congruent to 452 under mod 165. So we get a bigger value. So to reduce this to lower values, we can take as we have to divide 452 by 165. We get here we know that 165 into 3 is 330, which is is close to 452. If we subtract these two values, we get remaining is 122. So substitute in the place of this as 122 because 452 is congruent to 122 mod 165. Therefore, we can conclude that x is congruent to 122 under mod 165 is a unique solution for the given system of linear congruences. This completes the problem.